For any given series, we will give you, in this case, it is for given function, x squared over 1 plus 2x. We will ask you to find the series using the known one. So step 1, write down which one we're going to use, and I will give you a whole table today, which is going to be Maclaurin series. So we know, use this formula, we know 1 over 1 minus x. That is coming from the geometric series x to the n, and it's from 0 to infinity. Use this formula. That's going to be like one of the most important formula for your homework for now, and then others are coming. It is the first term over 1 minus common ratio. Then what we did was I rewrote x squared 1 over 1 plus 2x as x squared 1 over 1 plus 2x, because I see that the formula is 1 over stuff. And the formula is 1 over 1 minus input. That's how I see it. And then it will be sum input to the n. So I just need to have this shape, 1 over 1 minus input. Or if you like, use substitution, 1 over 1 minus u. So I do this like very common trick, x squared 1 over 1 minus, and now it's going to be my input, minus 2x. That is my input. From here, the sum shows up right away. Use the formula x squared sum. Input is minus 2x. That is my input to the n. I'm going fast because that's not new. We did it last time. But I want to do something important right now. So the problem asks, it's not the end. The problem asks find the series expansion. We already introduced the series using the geometric series, but we are not done. Geometric series has this equal sign. The big deal was to put the equal sign between series and the function. We're not done yet though. Let's submerge, that's not the correct way to explain it, but I like it. Submerge x squared into the sum. Remember, we're basically distributing. Sum is a stuff plus stuff plus stuff plus stuff plus stuff infinitely many. Multiplying by x squared means we can distribute x squared onto all of these terms added together. So x squared times minus 2x to the n, and it's from 0 to infinity. Some algebra going on here. I want to collect terms nicely. Minus should be standing outside. So let me do it slowly one more time so you understand the pattern. How to rewrite minus 2x to the n? You put n onto each term, but don't forget, -1 is also a term. It's a factor. So it will be minus 1 to the n, 2 to the n, x to the n. Does this step make sense? It's kind of crucial to understand that. So if you mess up on this step, the answer will be wrong. -1 sign indicates an alternating series. Now we're ready to answer. The final answer will be -1 always goes to the front. That is indication of the alternating series. It alternates sign. 2 to the n is coefficient standing in front of the variable. X, collect them. N and 2 gives you n plus 2. N starts from 0 to infinity. That's where we ended last time. We also find the convergence set. The moment my input changed to be minus 2x, the restriction was that minus 2x has to be less than 1 by absolute value. And we solved that last time. That gave us -1/2 to 1/2. So let me write down. This is possible only where the series converges. And the series converges for the input, which is absolute value of input, which is minus 2x is less by absolute value, which is x between -1/2, don't do that, -1/2 and 1/2. That is my convergence set with convergent center and convergent radius, or radius of convergence. So what's new today is they ask you for the coefficients. Let me help you with several examples to find these coefficients. And that is kind of annoying because you need to figure out how to be tedious and careful with coefficients. But that is exactly what we use in computer science. And I'll show you later why. So do you see the answer? The idea was to put equal sign between the function, a new function, and the series. And now we play with different kind of functions. X squared over 1 plus 2x, maybe you don't remember, but in calculus 1 we gave you a function like this and told you analyze it. And you was finding domain, if it's symmetric, periodic, well, depends on the school, that's what we do in this school. Then increasing, decreasing, first derivative test, second derivative test gave us concavity, concave up, concave down, inflection point, sketch the graph. So we did work with these functions before. Now we're making them to be serious, because that leads us to lots of applications in data science and so on. Coefficients are important. So let me do steps. Step 1, we know what formula to use. Step 2, we work with lots of algebra. Step 3, we found where this equal sign is even possible. Step 4, let's write down the coefficients. Coefficients. Sometimes people put S at the end. Coefficients. I just like C-O-E-F-F. What we do is we're going to plug our ends carefully, slowly. So let me write down one more time this amazing idea. Let me move this way. This amazing idea of the equal sign, because that's very important. So x squared over 1 plus 2x, the given function, now is equal to the alternating series. We found minus 1 to the n, 2 to the n, x to the n plus 1, starting from 0. This is what we found. They ask us to input coefficients. That's what usually you do in computer. Computer will be coded to build those series or to work with them. Computer will ask you, so what are the coefficients? Usually computer asks for hundreds. In your homework, they ask you for the 5 non-zero coefficients. Let's find them. What happens when n is 0? I plug n 0. It will be minus 1 to the 0, that is 1. 2 to the 0, that is 1. X to the 0 plus 2 is not 1. So it's going to be x 0 plus 2, x squared. Make sense? Let's plug n equals 1. We know it's alternating series. Maybe even write it down one more time. We did before. Alternating series. Because it changes the sign. It alternates the sign. I always know when I see alternating series because I see minus 1 to the n. That's a sign of changing a sign. Oh, wow, that's a weird phrase. That's a sign of changing the sign. N equals 1 will be negative right away. I don't have to think about it. The moment I figure out the first sign, all others now alternate. Plus, minus, plus, minus. So at 1, I will have minus 1 times 2 times x to what? 3. And now you can see the pattern right away. Do you see the pattern? When I plug 2, what is going to be? Plus 4x to the 4. Then n equals, change the sign, n equals 3. What's going to be? Minus, don't forget minus, plus, minus, plus, minus. Let's not write down 8, but I do see what you mean. It is correct. So usually to keep the pattern obvious, people rewrite 4 and 8 and others as 2 to the what? Second, 2 to the what? Third, x to the fifth. And now we see the pattern. So 2 to the first, but x cubed. 2 to the second, but x to the 4. 2 to the third, but x to the 5. X is 2 units higher than 2, which makes sense. It literally says that over here. It's n plus 2 every time. And then the sign changes, and that's the pattern. So technically speaking, now you can write down any you want without calculating too much. It just becomes plus 2 to the 4, x 2 more 6 minus blah, blah, blah. So they ask you to find the first 5 coefficients or first 5 non-zero coefficients. That depends on the question. So let's be very careful with what is asked here. Question 1. Find first 5 non-zero coefficients. C-O-E-F-F, coefficients. Non-zero means computer wants to know where the input actually makes a difference. If it's times 0, it means there's nothing there. Then the answer will be, again, this is keep pushing my nerves, go away. But we will need this, so I don't want to delete it. Now, non-zero, let's review what does it mean. Let me show you again. Power series has this shape or formula. Power series has a shape, either with a shift or with no shift. Here we don't have a shift. Sum a sub n x to the n. N is from 0 to infinity. And it looks like this. A sub 0 plus a sub 1 x to the 1, a sub 2 x to the 2, a sub 3 x to the 3, plus keep going. So, 1, 2, 3, 4. Let's do one more to have 5. A sub 4 x to the 4, and keep going. A sub I, that's how they call it. A sub i's are coefficients. Basically, whatever is attached to the variable. No matter if this variable was a shift or not. Those are our coefficients. They called A sub I. A sub I are coefficients. And that's what we're asked to find, either 5 non-zero or 5 in general, or 10 or 100. So in your computer, in the code, you actually plug those numbers, 7 minus 2 minus 3, and computer will build the series from the coefficients because it knows the shape. So x to this stuff has a pattern. Coefficients are the one that actually will define the series. So this is the review. Let me put this in the box. Knowing this information, now we can answer the question from what we already wrote. We wrote those coefficients out. The first one is 1, the second one is minus 2, the third one is 2 squared, minus 2 cubed, why so small? Then 2 to the 4, and so on. So the first 5 are actually here. The first 5 non-zero coefficients are a sub 0, a sub 1, a sub 2, a sub 3, and a sub 4. Equal, 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 equal. The first one is 1. They all agree 1 is multiplied by x squared. So 1 minus 2, 2 to the second, minus 2 to the third, 2 to the fourth. And if we want to, we can even figure out the pattern. To be honest, you can sometimes write down the formula for the coefficients. And the formula will be formula. So if you code it in the computer, you tell computer, okay, just 5 is not enough. Give me 1 million coefficients using this formula. A sub I will be minus 1 to the n, 2 to the n. Well, we use I. Well, it's fine. And let's have n. N starts from 0 to infinity. This is how we code it in programs. C++, Java, Python, R, whatever you're working with, MATLAB. This formula, we found it ourselves right before that. However, What's confusing part is, which already was asked by several people, is sometimes they ask you to find something else. So, which is this? Those are non-zero coefficients. So we keep them here. Why it is a different question, and that's a bit confusing to explain. If we ask all first 5 coefficients with zeros, what is going to be the difference? And that is confuses people so much because you need to understand what is missing. Let's see. Here's the formula in front of you. Find differences between what we have and the formula. The formula is a sub 0, a sub 1x, then x squared, then x cubed, then x4, and x5. Our formula is x squared, x cubed, x4, x5, x6. What's the difference? Did you notice? Something is different. What? And I'm talking about this box. I'm talking about this box. Compare blue box with the red box. What is the difference? And of course, their coefficients are different. But then we have x to the powers. So what is different? The very first two are missing. Where is x to the 1, which is over here? X to the 1. And where is isolated coefficient, which usually we call x to the 0? X to the 0. Where is coefficient attached to x to the 0? Those are zeros. So, to tell the computer that those are zeros, we have to actually put them in the list. Then a sub 0 is 0, a sub 1 is 0. And that is confusing that in this homework and in the real life applications, we'll be asking you different things. And that's what your degree gives you, understanding of this difference and which one you're using in data science. So the first one is 0 and the second one is 0 because it's 0 times. So because it's 0 multiplies to x0 and then 0 multiplies to x1 in our specific series. Then these start. Then a sub 2 is 1 because it was 1 to the x squared. Then a sub 3 is minus 2 because it was minus 2x cubed. Right? Let me check. Yes. Finally, the fifth one will be a sub 4, which is plus 2 squared. 2 squared, because 2 squared was multiplied to the x to the 4. See? That is a different way of seeing what is the formula. The second way is correct. The first one is not correct, but homework likes to ask to do that. So the second one is correct. This is what we use in computer science. We always tell computer which coefficients are missed. The first two are missing because they're zeros. Thing is still exists in the formula. If it's missing, it just means x is multiplied by 0 coefficient. 0 coefficient is information. So when we code the sound system, like so, in the computer, every time you hear a noise, so this is, for example, a sound recording of the bird singing in the forest. You go there with equipment, you put equipment, and you're recording, for example, you're a bird scientist. So you record birds communicating and singing. But there's lots of noise happening, and this noise is wind and the sound of leaves and the water. You go back to your computer and you tell your computer, this noise make coefficient 0. And this is how noise canceling ideas were created. It's a bit more than that, but it uses series and then set to 0 the coefficients of the variables that represent the noise, and we can detect which one they are. They're usually smaller than the one we need. The bird singing will be like so, high and low. But the small ones, weird sounds, you can see them from the pattern, and you tell computer, put zeros there, and it eliminates the noise. This is how cool the applications are. So the zeros are important. That's why the second way is better. The first way is not good, to be honest. But you will see, it's not wrong. You will see it. That's why I wanted to show you that it's still there. What do you think about that? Let me show you one more, so you can do homework, more homework. After this, we're gonna go to the next chapter and we're gonna build this series. Don't have to write down them right now. You will write down for the next chapter. Those called Maclaurin expansions or basic Maclaurin series. I need to teach you how we're gonna find them. But we already found this one. This was found 1 over 1 minus x as a geometric, don't have to copy this. I will show you later when to copy. Geometric series. And from there, we found a logarithmic series. What is the series? So isn't it amazing? I try to push the idea to appreciate it. You don't have to trust me, but it is very important. Logarithm function has a series. Like, how cool is that? The logarithmic function we know from school has its own series. Isn't it cool? Or sine and cosine we know from school, from geometric classes. We hate it so much. Have a series too. When you was learning all those pi over 4, pi over 3 angles, it also has a series expansion. And if you go to imaginary world, complex analysis, it has its own there as well. It's pretty cool. Exponential function we know so well, that goes into bacterial mutation and business formulas. Has its own series expansion. Isn't cool as well? And this actually involves lots of factorials. So until we go to those three functions, the first one and the last one, we can find right away. The first one is geometric series. Do you know how can we find this one? From the geometric series. There are two formulas we figured out from the geometric series. Arctangent was the previous one. Arctangent was the one we found last time. Arctangent of x we found last time. Do you remember how we found it? That was some kind of integration of 1 over 1 plus x squared. You don't have to memorize it, luckily it's fine. But can you guess how we're gonna find this log from 1 over 1 minus x? I'm pretty sure you're guessing it. Derivative, yes. Derivative of log gives you 1 over 1 minus x. That is correct. But we know the first one. So we're integrating. If I integrate, integral of 1 over 1 minus x dx gives you natural log 1 minus x divided by negative sign though, minus plus c. So from here we can find log of with the plus with the same method we did before, and I'm going to show you right now how we're going to do it. So from geometric series we have at least three basic formulas. Arctangent surprisingly, log not surprisingly, and others are coming from a different formula. So we're going to use this formula to do this homework problem, which is I think number 8 from 8.6. Example. If you have a function given as 2x times ln 1 plus 2x, find the series expansion for this function. Find basically the equal sign between the function and the series. And then they ask you to find how many? Write down the first 5 coefficients. You see, not non-zero, the first 5 coefficients. The first, so A, find the expansion. B, just a second, find the first 5 coefficients. There was a question? No? Oh, you said blash. Okay, sounds the same. So, solution, and this is exactly the steps I just showed you. Step 1, choose the formula you're gonna use. We are going to use formula for logarithmic function. Why? Because I see logarithmic functions. So I scroll to the table. and I will see, okay, so we have this log. Okay, fine. It means we will use formula for log. Let's write it down. Use the formula that log ln of 1 plus x already has a series. It's a sum minus 1 to the n, x to the n plus 1, all over n plus 1. N is from 0 to infinity. We already know this formula. I know you're kind of thinking, I don't know this formula, what does she mean? We used to enforce students to memorize all of these formulas. So this table is supposed to be known. So I was forced to memorize everything by heart, and I did. Unfortunately, it's hard. You guys also used to be forced, and then I became coordinator and started pushing the idea. Well, I'm advocating for people with bad memory because I have one. And then we push it through, and now you will have this table on the test. So for like 2 years already, we give this table test, so people don't have to memorize any of this. I think that was a very good idea. So we're gonna use this formula. Your job is to know how to use it. Step 2. Okay, let's figure out. 2x times ln 1 plus 2x. 2x will wait for some time to be distributed later. What we're gonna do, we're gonna figure out the 2x situation inside of the log. Well, basically, this is my new input, where the input in the formula used to be x, now it's 2x, nothing new to figure out. So it's gonna be 2x, and now we use the formula, and we will have the sum minus 1 to the n, means the logarithmic function has an alternating series. New input over n plus 1. New input is 2x, and new input is raised to the n plus 1. So maybe let me put here. 2x is my new input. The old input, I will call it x in pink. It's kind of like U substitution if you want to see it this way. For you to know, this notation, the way I wrote it down, is not incorrect. Well, it's not a mistake, but if you want to be professional, I like to teach mathematical literacy. It's international language, so if you show it in Japan, people actually know what you're talking about. In Ukraine, in France, you write down this. People who took calculus class, they know, they say, oh, this is a serious topic. I don't remember what you guys doing here, but I can see it's an alternating series. So I'm gonna erase the sum and put it like so. The nose, well, it's kind of ugly. The nose should point out to the fraction, like so. That's kind of the notation. From 0 to infinity. That is not the end. We need to distribute 2x. So I would like to like submerge this 2x into the sum notation. That's basically distribution. Nothing more than that. So equal sign, I will have this sum, the fraction. Don't touch minus 1 to the n. Don't touch n plus 1. That is already done for you. It's fine. What is new is in green color 2x. Come on, I said green. Green color 2x will be now inside, and then the pink 2x is still there, right? N plus 1. So now I can write down this. N is from 0 to infinity. N is from 0 to infinity. It's minus 1 to the n, and then 2x raised to what? N plus 2. Thank you. Good job. Now, sometimes people will ask you to take out the 2. Then it will be 2 to the n plus 2 and x to the n. But actually, it is not always correct. We want to keep this shape to see what is keep changing, what is raised to the n plus 2. I will show you both ways, so don't worry about that for now. Let's see. This is the answer number 1. This is what people are gonna write down or type in the computer. The function 2x multiplied by logarithmic function 1 plus 2x has a series expansion. This only works. So this equal sign only exists with a series convergence. But we know we're in convergence where the new input, which is 2x, is less than 1. So it converges from minus 1/2 to 1/2 with the center of convergence 0 and the radius of convergence 1/2. Make sense? Now, more. We can rewrite it like so. Minus 1 to the n, 2 to the n plus 2, and x to the n plus 2. This is usually what people code in the computer because variable should be standing by itself in order for computer to know where are the coefficients. Coefficients will be here in light green. These are my coefficients. Oh, come on. People call them, in this case, A sub n. Those are my coefficients. Coef, C-O-E-F, C-O-E-F-F. That is also a correct answer, but it is a better correct answer, if you know what I mean. I don't know. It's just, that's what people would write down around the world most of the time. So, this is not the answer. We answered A. A asked us to find this sum. We did. B asked us to find 5 coefficients. Okay, that means, yes?
I'm sorry, so for the first box up there with below height, so right there when you input the 2x, I think I blinked when this happened, but the 2x in green and the 2x in red.
Yeah.
What happened to the 2x in green? Did it get turned into the 2?
No, check it out, check it out. Thank you for asking. So I did it, I put it here in green. Now I have 2x in green and then 2x in pink, and the one in pink was raised to the n plus 1. Now I have 2x times 2x to the n plus 1. That becomes 2x n plus 2. Make sense? Yeah. Do you see? That was a small algebra. If you blink, it doesn't make sense at all. So that's exactly what I want people to ask when they get lost. Small things, and I can answer in 5 seconds, but now it clarifies everything. Nice. Equal sign goes to the B part. When I plug n equals 0, it gives me minus 1 to the 0 is 1. 2, 0 plus 2, that is 2 squared. X, so let me tell you what I'm doing. I'm plugging n equals 0. X 0 plus 2, it's x squared over 0 plus 1, that is 1. Stop doing that. That is my first term. Plus, let's plug n equals 1. That's basically writing down the expansion. That's usually sometimes we also say that let's write down the series expansion. Maybe let's write it down for you so you know. That's called a series expansion. We're gonna expand the series. That's why it's called expansion. Expansion. When n is 1, now I know it's going to be minus. And it's an alternating series, so I know it's going to be plus, minus, plus, minus. The first term defines the beginning of the change of the sign. So since the first one was plus, everything will be plus, minus, plus, minus, plus, minus. Minus 2, we plug 1. So 2 raised to the 1 plus 3, that is 2 to the third times x to the third over 1 plus 1 is 2. Do you see the pattern? So denominator will be 1, 2, 3, 4, 5, 6, 7. The numerator will have powers 2, 2, 3, 3, 4, 4, 5, 5. Plus, minus, plus, minus, plus, minus. So 2 to the 4, x to the 4 over 3 minus 2 to the 5, x to the 5 over 4. And keep going. We need 5. 1, 2, 3. No, not enough. 1, 2, 3. 1 more plus 2 to the 6, x to the 6 over 5 minus da. So we plug in I said and blue, seriously. And blue is 2, and then 3 and then 4. Those are the 5 terms I just wrote down. This is not the answer, but I wanted to stop here and ask, do you understand what is happening? We're playing with numbers, plugging the terms in order. Yes?
If you were to have like the non-zero stereo, if you were to have zeros, would there be 2 zeros?
Very good question. So I'm actually getting there. Yeah. That's very important, so I would really want to push this idea right now. The calculations, though, did you get the calculation? Because that's also like those little things. It's nice to explain them in class. Now, we're asking you to figure out the coefficients. Let me put it in yellow. Check it out. Coefficients are 2 squared over 1 minus 2 cubed over 2 plus 2 4 over 3 minus 2 to the 5 over 4 plus 2 to the 6 over 5. Let's write it down and now see what's going to happen. I need a sub 0, a sub 1, a sub 2, a sub 3, a sub 4, 5 coefficients. The important part is to see what they asked me about. Are they asking just coefficients or non-zero coefficients? Come on. Just coefficients. I just wanted to show here. Find the first 5 coefficients. The formula is very strict. The formula is at the very beginning of this chapter. If you go to the very top of those lectures, you will see this formula I gave you. This is the formula. It says the formula starts with x sub 0. No, sub 0, x to the 0. The formula starts with x to the 0. Then it has x to the 1, x to the 2, x to the 3, and so on. Let's check about our series. Our series starts with x squared. That means the first 2 are missing. 0, 0. Just like last time. Does it make sense? How would you tell a computer that we need to start with x squared? You put zeros at the very beginning. If you tell a computer it starts with 1x to the 100th, you put 0 to all 99 before it. And a computer knows, oh, that's what's happening. 0 times x to the 0. 0 times x to the 1. And now the other one comes in. 2 squared over 1 minus 2 cubed over 2. 2 to the 4 over 3. These are multiplied by x2 and x3. Those are non-zero coefficients. So this answer indicates 5 coefficients. Keeps doing EE for some reason. 5 coefficients. If they ask you 5 non-zero coefficients, then you answer whatever I wrote in yellow over here. All non-zero coefficients. All 5 non-zero coefficients. Let's do that just to have comparison. See 5 non-zero coefficients. The first 5 non-zero coefficients, of course. You don't take like one in the middle unless they ask you. Then a sub 0 will be 2 squared. A sub 1 will be, and that's why they're renaming it to C. Actually, in your homework, you can see they're renaming it to something else to make sure you don't confuse them with the formula. Let's do that too. I guess it's a pretty good idea. They're renaming it C sub 0, C sub 1, C sub 2, C sub 3, C sub 4, because it's not the same AI we had for the previous one, which is very strict in the formula. So we're going to have 2 squared over 2 minus 2 cubed over 2 or 3. Oh, yes, over 2, that's correct. 2 squared over 1 minus 2 cubed over 2. 2 to the 4 over 3. Now you can see the pattern. I don't even have to look it up anymore. Minus 2 to the 5 over 4 plus 2 to the 6 over 5. Let me check. Looks good. Matches with yellow. Those are 5 non-zero coefficients. This question is asked sometimes. Do you know when? It asks what if first 12 coefficients are missing for some reason? Maybe the first 5 minutes of the sound recording had noise only. So like you did not bring it to the forest yet. The bird did not start singing yet. So the first 5 minutes was just noise. And the noise is happening. And then some cool stuff is happening. The bird is singing, and you want only that recording. You tell computer to kill the noise at the very beginning as well. So you tell them, okay, the first 15 coefficients are 0. But then scientists ask you, well, give me the data. I don't need you to first 15 coefficients to be 0. That has nothing to do with the data I wanted this to work on. So they tell you, give me non-zero coefficients, the first 100 non-zero coefficients. And this is when you skip the first 2 and then give the data. And the data has recording of the bird singing. And that's exactly how the noise canceling ideas are working. And image clearing of the image as well. I'll show you later. It actually has pretty cool ideas there. What do you think about that? So 0 coefficients and then non-zero coefficients. That will be confusing for your homework, and when you get confused, you know what to do. What? Post your question in the forum. And we're gonna help you to solve it faster. Not too bad. It is tedious and new, but it's extremely important. So, probably we should go back and write down over here when we did this inequality, just to have a good note. When we found that x is from -1/2 to 1/2, that is called a convergence set. We know that, that's not new. Convergence set. Radius is 1/2, center is 0. This convergence set is very important because this equal sign cannot be where the series does not converge. This equal sign I'm putting between the function and the series. This equal sign over here I'm putting between the function and the series cannot happen if series blows up. Because logarithmic function times x exists. And we can put this equal sign with an infinite alternating series only on a safe space. In a safe space, that's my joking way to mention a convergence set, or set of interval of convergence from -1/2 to 1/2. That came from the knowledge. Yeah, that's true. That this input to x should be less than 1 by absolute value. That came from the geometric series.